Continuing, now that we know a few things about gas laws, interesting that we all finished at the same time.
It's almost like they all simultaneously.
That's one of the more interesting combinations I've ever seen.
I was waiting for you.
Oh, okay. Anyway, gas law applications. Now that we are familiar with the relationships between the various variables with gases, we can start applying it to maybe a little bit more lab-based ideas. Before we get started, though, I want to remind you of this. This will possibly be the third time you've written this down this year. But it's been a while, so you may want to do it again. Because I'm going to add something to it. So far, these are the three things that we've looked at, this relationship, right? You guys all got very comfortable with that, I thought anyway. But we're going to add something now. And that's called the molar volume. Of any gas. But as we've learned, their volumes are influenced by both temperature and pressure. So this only applies at standard temperature and pressure. So if you see the phrase, a gas at STP, or standard temperature and pressure, then you might possibly be looking at using the molar volume idea, okay? Now, here's what's interesting. That is equivalent to 22.42 liters. So any gas that has standard temperature and pressure, 1 mole of that gas will have a volume of 22.42 liters. Can anyone think of any maybe everyday object that might have a volume of 22.4 liters or so? I've found over the years that my students aren't really very aware of exactly what is 22 liters.
Maybe a bathtub.
A bathtub, that often comes up. Anything else? 22 liters.
I can't think of anything as big as a bathtub.
I didn't say bathtub was right. That's just usually what's offered up.
Ah.
Yes?
Well, I mean, like, I'm picturing like 2-liter bottles, so maybe like a kiddie pool or something.
A kiddie pool, okay. Anyway, kiddie pool, we have bathtub, kiddie pool. Toilet, usually get toilet in there. What was that? I heard that one. Washing machine I usually get. You say sink. Now, at home I've got a bathroom sink and I have a utility sink.
Like for washing dishes. Something like that.
Oh, like a kitchen sink.
Yeah.
Is that kind of what you were thinking? A kitchen sink, okay. What were you saying? Hot tub usually comes up.
Well, if a kiddie pool, there's a small kiddie pool.
So we're all over the map, wouldn't you say? We're talking bathtub, a kiddie pool, a hot tub. Of all these things, which is the largest that's been mentioned so far, do you think? Probably the hot tub. What's the smallest so far, do you think? Toilet, maybe the kitchen sink. Okay? 22.4 liters. Well, usually, or often at this point in time, depending on the classes that I have, how much time I have on hand, I have in the past done a couple of different things from now. There are a handful of classes, it's been a long time since I've done this, where I've actually provided a bunch of cardboard to my students, and some scissors or knives or something, and some tape, and a meter stick, and say, here, construct something out of this cardboard that will contain a volume of 22.42 liters. Okay, well, obviously the easy part is actually putting everything together. What's the hard part? Figuring out how big everything should be, would you agree?
Yeah.
So that's probably the hard part and probably the most important part. So what I'm going to do is give you guys about 2 minutes or so to come up with the dimensions of if I were to hand you a bunch of cardboard, come up with the dimensions that this cardboard box would have that would contain a volume of 22.42 liters. Now, what would be the best shape to make? Round. A round cardboard box.
Jenny had a cardboard box.
I heard somebody say a square. Unfortunately, volume isn't three-dimensional. Oh, maybe a cube. Okay, so there we go. So there we go. What dimensions does our cube, which would probably be the easiest thing to do, need to have in order to have a volume of 22.42 liters? I'll leave you to your own devices for a few moments.
If I knew the conversion between cubic meters and liters,
I know, so.
These are really small.
Close up.
Yeah, don't play respond on his own.
This is fucking
And we'll have your ass You just lost your Apple Watch.
It wasn't even Apple, it was like a Samsung.
Oh my God.
All right. So what did we come up with? I'm going to give you some cardboard. What?
There you go.
I don't like
No.
cardboard.
I think a sphere would work.
It's what?
A sphere.
A sphere. Would work?
Yes.
So you're going to take some cardboard and make a sphere out of it.
Yeah, like, yeah.
What you got, William?
Well, I wasn't able to come up with an actual number.
Then why are we having this conversation?
Because nobody appears to be even coming up with anything. I did manage to come up with how we could get the answer though.
We were talking about how messy stand back about this.
I'd say
I'll break
five.
it.
Is this gonna be like a trick thing, cause we're talking about gas and it's
A
like.
volume is a volume is a volume is a volume.
That's it.
No, don't say. Figure it out.
Oh.
You're going to make a box, people. A cube. What's this going to be?
The base.
What dimension?
Like,
Oh my gosh.
I'm so confused.
This explains a lot of things. Go ahead,
Oh, wait.
Colin.
Oh, no,
7.473.
7.473. By golly, I have no idea what you're talking about. 7.743 what?
Inches.
Inches.
What?
The inches part was like the length of that.
Oh,
Oh.
That's
you
what I was
just-
talking about.
I understand what you're saying. You had no idea what the unit was, did you?
Not the inches.
Well, that's kind of important, isn't it?
But the number is very.
you would have to figure that out.
Ben, please use your brain.
What?
I'll try this again.
It's not gonna work.
What?
When he walked out, he was like, "You don't use your devices." So it's supposed to be like our phones saying,
Oh, yeah.
A rectangle.
No, he's not rectangle.
Derek's probably right. You could.
No, I'm just playing. I'm not gonna get it right.
No, Derek, I
I don't know how we're supposed to.
Every time I use my hand, I always answer.
I'm trying.
Don't look it up on your, no, use your brain.
You said use your device.
Use your, no, I didn't. I left you to your own devices. Your brain. Use a brain. Apparently you guys do not have lost the ability to use the brain.
Yeah.
Push.
This is not learning.
What we got?
Which is the 7.473
7.743 centimeters.
7.47.
7.473 centimeters. How did you arrive at that answer?
I divided 22.42, or divided by 3.
Divided it by 3.
Because it's going to be cubed.
Like times what times what?
Yeah.
I think it was
No.
That's right.
Yes.
What?
2.82?
2.82 what?
Oh,
What's wrong with Collins? What is wrong with Collins' suggestion? That's often the first place people will go. What's wrong with Collins' suggestion? What are the units? Pick a unit. Centimeter? Okay. So if you said 7.437 centimeters times 7.437 centimeters times 7.437 centimeters, what do you come up with for a unit?
Oh, cube centimeters.
What's wrong with Collins' idea?
It's not.
He divided it by 3.
You gotta do the cubed root,
Therefore, when you do that, you get,
2.8.
and what is the unit? You just took the cubed root of 22.42 liters.
Liters.
No, it's more like.
Cube liters.
Liters
Cube.
cube root.
Cubed root liters.
That's a fairly common unit, isn't it?
No.
No, it's not at all. 2.82 what? A lot of people say meters. Well, here is 2.4 meters. So you're saying length times width times height. You think we can fit 11 2-liter Coke bottles in there?
Yeah, we
I
can.
think so.
Times 1,000.
Yeah.
Are we wrong?
Are we wrong, she asks.
It's inches.
Inches?
Yeah.
Yeah, we deal with inches all the time. Did you swear at me? That's it, I'm sending you to the office.
Everyone said inch.
Centimeters, perhaps. Oh,
That's too small.
two, a two.
Decameter?
Kilometers.
Or decile?
Is that even bigger?
You know, this is all kind of amusing and funny and all that kind of fun, but it's also very, very sad. It's very, very sad.
There's a.
Yeah, there's a bunch
There's a place.
of them. Yeah,
Really?
yeah.
Literally, it's probably.
Oh my gosh, people. I'll give you a hint. Something that you know.
Oh, yeah,
Say this again. Well, as it turns out, this is the quantity that you guys are actually trying to solve for in your lab.
Good thing I didn't turn it.
Somebody help me out. How can I relate this
You can.
to this? Colin?
You can get the centimeters cubed of the lengths and stuff. Like having the centimeters of the length and the width and the height.
Yeah, right.
You can get a cube.
I can get a centimeter out of that.
And then you can get-
But what else do I have to do before I get there?
You gotta turn milliliters into liters, or liters into milliliters, sorry.
Therefore, this many liters is going to become,
Over 1 milliliter over.
I'll give you a hint.
So you're
Point
1
zero.
liter, 100 milliliters
0.001 liters.
per 1,000.
Oh,
You were right.
yeah. Oh, same thing.
You can do it the same way. And now,
What is it?
no, just what do you do next?
Multiply. Oh, no, now you go to centimeters. So 1 centimeter per liter.
And as Allison just said, 22,420 cubic centimeters, which now, William,
You cube.
and you get 28.2 centimeters.
How long is that? Like,
That's a darn good question. How long is that? As it turns out, my little sample that I gave up here was not incredibly far off. There you go. Whoops, fumble. Gotta take my glasses off. There we go. All right, so there we go. Now we have a box that has a volume of about 22.42 liters. What would you compare that to? I'm sorry, what's that? Yeah, the sink here. That's a pretty good darn guess. Okay. Yeah, that's about it. Okay. Now you have an idea, though, when I say 22.42 liters, because up until this instant you had flat out no idea whatsoever. Okay, now moving on. We're going to do all kinds of things with this, and because we wasted about 10 minutes doing that, we're going to have to fly. And if we don't get done, you're just going to have to watch the video, and there is an assignment that is due Thursday or Wednesday, whenever it is I see you next. So, here we go. First off, let's apply this a little bit. What if I had 3.82 liters of, say, nitrogen at STP? What volume, or sorry about that, how many moles? Would that be? Now, just like that phrase, collected over water, tells your brain to do what? find the relevant water vapor pressure to subtract the water vapor from, right? As soon as you see this, your brain should be going, I should probably be able to use this relationship. Can we use that relationship? Is there a relationship between volume at STP and moles? 1 mole is equivalent to 22.42 liters. So here we go. We take our 3.82 liters of nitrogen, look at the relationship since we're at STP, and essentially in this case divide. So we're looking at what? Two-fifths. All right, 1/5, so around 0.2-ish. A little bit less than that. 1.7, I need another significant figure. Oh, really? Wow, weird. Say this again?
0.170.
Point. Yeah, because I said around point. Okay, so around 0.170 moles of nitrogen. Pretty straightforward, wouldn't you agree? Okay. Second example. What if I had 14.38 liters of, somebody give me a gas. Okay. Oxygen at STP, what mass might that be? How are we going to find out? Okay, is there anything up there that kind of rattles our brain a little bit? Volume at STP. We're trying to find grams. Is there anything I can find from volume at STP? Moles, perhaps. And once I get to moles, I can get to grams. So, 14.38 liters, 22.42 liters per mole. And as we all know, oxygen is 32.00 grams per mole. So, 1.5,
20 all
20-ish.
that in one step.
Like put this
Yeah.
here, like we did earlier this year. Do you remember doing that?
Yeah.
Yeah, there were times when I did that. Yeah, sure. Because your yeah, as you see, your moles can cancel out, right? Absolutely. Some people like the moles. Some of you prefer to go to moles. That's fine. Some of you would see that relationship and would just put the two together. Right? Remember I said you can pick any two of this set of equivalents to make a converting factor. So did we get around 20-ish? 20.52? Okay. So we get 20.52 grams of oxygen. And all this is hunky-dory because we are at STP. Makes it nice and easy. However, how often are we at STP? Well, the standard pressure part, especially the way the weather's been here recently, we get pretty darn close to that. What's the part that's probably not really close to standard temperature, which is, remember, 0 degrees Celsius, which is the freezing point of water. It's not currently at that point. So, how can I use this relationship or this idea if we're not at STP? Well, let's try this. Oh, gosh. 1.48 liters of, I need another gas. All right, you guys aren't gonna know anything. Sulfur dioxide. 738.0 torr and 19.6 degrees Celsius. This is example number 3. So we have 1.48 liters of sulfur dioxide that was measured at 738.0 torr and 19.6 degrees Celsius. What is its mass? How could I get there? Anybody have a path that they could help us get there?
Find,
Say this again?
Do 1.48 times 1 mole.
Over the 22.42?
Yeah.
That would be lovely if we were at standard temperature and pressure. But we're not at standard temperature and pressure. But keep going though.
Can we get there? Can we put that in standard?
How?
Uh,
He asked, can you convert this
Yeah.
to standard?
yeah, isn't it like, well, I was talking 738.
Yeah.
Yeah, you do 738 times, but 1 ATM over.
What have we been doing for the last couple of days? Converting non-standard conditions to standard conditions, right? And so if we know the volume at STP, we can then, Derek, use this to find moles, and once we know the moles, we can find the mass. So here we go. We're going to have to do the V1 P1 T1 equals V2 P2 T2. V2 equals what? V1 P1 T2 over P2 T1. So we plug and chug, and we get 1.48 liters times 738 torr times, well, what do we have to do?
Add 273.2.
Yeah, so I'm going to add 20. So what are we going to do? 293 and back it off by 4. So 292.8. Somebody can check me on that. 6? All right. And then second pressure is going to be 760 torr. And the other temperature is going to be 273.2. Well, let's do that over here. No idea what that's going to give us because I'm making these up as I go along. However, well, I'm not really sure which way it's going to go. Would that not be hilarious if we came up with 1.48 liters? That's happened before, by the way. Anybody have their calculators out?
Wouldn't it be 292.8 Kelvin if you were adding 273?
See, that's exactly what I said and she said. What's that? Thank you, Rachel. And possibly Cullen to verify, unless you have it already, Michaela. What do you have, Rachel?
1.54.
That's close. 1.54 liters. If anyone can confirm that, would be lovely. Okay, so now that's 1.4 liters. However, remember, this is now at STP. So this is where Derek tried to jump in. He said, hey, can't we just use the 22.42 liters? Well, we can now. Because we're at STP, which is the only time that's going to work out. And now my liters cancel. And now that I'm in moles, I can just go ahead and convert that to grams. SO2 is 64.10, I believe. Somebody can check me out on that one. And there we go. Let me see. 3206. Oh, I lied. It's 06. 3206. Okay, whatever that comes out to be. So we're talking about 3 times more than that, so around, what, 4.5-ish? 4.4, 4.4 what? 0 grams of SO2. So really, it wasn't any different than exercise number 2 that we did, or example number 2 that we did. It's just that in example number 2, we were at STP, so we can directly go to this. In this case, we were not at standard temperature and pressures, so we had to convert to standard temperature and pressure and then go forward. Same question. Okay, next. So there's how we can use the molar volume, both at standard and non-standard conditions. We can also consider the density of a gas. Well, what's the equation for density? Oh, come on now. Let's go back to 4th grade. Okay, I lied. 6th grade. Mass over volume. Okay. Now, if we're talking about the density of 1 mole of gas at standard temperature and pressure, well, do we know the mass of 1 mole of gas? What do we know that as? Molar mass, right? And does anyone know the volume of 1 mole of gas at standard temperature and pressure? Maybe it's written right here. In which case, it would be the molar volume. So, for example, what's the density of, somebody pick a gas, propane? C3H8. Does anyone happen to know the molar gas of propane, or the molar mass of propane? Okay, those with the calculator, 3 times 12.01 plus 8.08. What is it? 44.1 what? Does anybody happen to know the molar volume of propane at STP? This tells me how much you're paying attention. Thank you, 22.42 liters. Notice that my moles cancel out. It's going to be right around 2, a little bit under 2, just barely. Anybody have that? .967, so 1.97. Ah, you're right, 67. Now, what are the units? Grams per liter. Does that sound weird? Grams per liter? How are you guys used to expressing densities? Grams per milliliter, grams per cubic centimeter, right? Why is this okay? It's a gas. We know about the density of gases. They're very, very less dense than solids and liquids. Or would you guys rather do this? 0.001967. Yeah, you guys hate that number, don't you? So that's why we don't do that. So gases are typically expressed in liters, grams per liter. All right, and lastly, where are we on time?
9 minutes.
Excellent, molar mass. What are molar masses given in? Does anyone remember this symbol right here? We used that for molar mass earlier this year. Does anyone remember what units molar masses are given in? You're going to be half right when you say it. Well, we just calculated like 5 of them. What's that? Okay, they're given in grams per mole. I'm really, really concerned with your guys' ability to be successful on our next test. Grams per mole. So here's an example. Let's say we have a 1.25 gram sample of gas has a volume of 350 milliliters at 20 degrees Celsius and 750.0 torr. Find its molar mass. Well, once again, what do we need to find molar mass? Grams and moles. Do we have either? We have the grams. We're halfway done with the problem. Well, it looks like we're halfway done with the problem, but we're not. We need to know the moles. All I know about this gas is that we have 350 milliliters at this set of conditions. Can I somehow get to moles from that? Well, look at example number 3. What do we do? We had a volume of gas at non-standard conditions that we converted to standard conditions, and once we converted to standard conditions, we use the molar volume, find out how many moles. That's all you have to do. It's not that hard. So we go V1, P1, T1 equals V2, P2, T2. V2 equals V1, T1, T2 over P2 times T1. And we just plug and chug at that point. So we have 350 milliliters, 750 torr. Now I could have asked that this gas was collected over water, at which point what would I do now? Subtract the water vapor pressure from this, but I didn't do that this time. And then T2 is 273.2. P2 is 760 torr. And T1, we're going to have to add 20 degrees Celsius, which we all know by now to be 293.2 Kelvin. Now that's going to give us a volume at STP. I don't know what that volume is going to be. Somebody can probably calculate that. Or would you rather determine the molecular geometry of this unknown gas?
Okay.
All right, anybody have a volume here? It's going to be more or less than 350. It's going to be less than 350. Both changes give us a smaller volume. Does anybody have that volume? 321.8, you say. Now, that is at STP. So, first thing we have to do is convert that to liters. Then, we can use the molar volume. 22.42 liters per mole. Then, that gives us a number of moles, whatever that happens to be. So this is what ninth period looks like, huh? All right, anybody have any moles here? 0.32, it's going to be small. Point what? 0.01435 moles. Okay, so now all we have to do is come up here and say, okay, we've got 1.25 grams. We have 0.01435 moles. Basically multiply that by 7. Yes?
I have a question. If we didn't turn the lab in today, do you want to turn in next class period or tomorrow?
That's an excellent, excellent question, and thanks for asking that question. In the old days, when I was mean, there would be no questions asked. It'd be due tomorrow. But since I'm no longer mean, I'm so accommodating and so very, very easygoing now, I'll let you turn it in next time I see you. And you guys think that I'm being a little facetious there? I'm not. I mean, before, nobody would even bother to ask that question because they would know it would be the next day. Anyway, moving on. Anybody have an answer here? 87.11 grams per mole. The only thing I have done to your lives, people, today is this right here. That is the only thing I have added to your life today.
That statement is correct.
There is not a single thing up there that's different than what you've already done.
Well, that is also the idea of like molar density.